Black holes, what they really are. A black hole is a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. When anything like a spaceship, even the sun, comes too close to a black hole, the gravity of the black hole is so strong that the object cannot escape, even if it traveled at the speed of light. The distance from a black hole inside of which nothing can escape is called the event horizon. Supermassive black holes. As the name suggests, supermassive black holes contain between 1,000,000 and 1,000,000,000 times more mass than a typical stellar. That's how you say it, right? Black hole. The only mechanism capable of producing such enormous amounts of energy is the conversion of gravitational into light by a massive black hole. Over time, they shrink down to nothing and simply pop away in a flash of energy. It's not exactly that fast. A good-sized black hole, say a few times more massive than the sun, will take about 100 to something years to eventually evaporate through this process known as the Hawking radiation. Similar to black holes, quasars, images of quasars on slide 5, suck in anything in their path, and plus, these things contain plasma and black holes. In reality, the light comes from the accretion disk around a supermassive black hole. The disk is so bright that the galaxy around it cannot be seen. There is a black hole behind every quasar, but every black hole is not a quasar. Specifically, a quasar is a supermassive black hole that is actively feeding on material. A blazar is an active galactic nucleus with a relativistic jet directed very nearly towards an observer. Relativistic beaming of electromagnetic radiation from the jet makes blazars appear much brighter than they would be if the jet were to be pointed in a direction away from Earth. A pulsar, originally short for pulsating star, which is probably in the background, is a rapidly spinning neutron star, the remnant of a supernova explosion. A quasar, from quasi-stellar radio source, is in fact a distant galaxy with a fluctuating blaze of light and other radiations coming from its central regions. When two black holes spiral around each other and ultimately collide, they send out gravitational waves, ripples in space and time that can be detected with extremely sensitive instruments on Earth. If confirmed, it would be the first known light flare from a pair of colliding black holes. Some of these black holes also blast out gigantic superheated jets of plasma at nearly of the speed of light. The primary way that the jet discharges this powerful is motion energy that is converted into extremely high gamma rays. The concept of a supermassive black hole and its surrounding disk of gas is typically such an vent that would leave no visible trace. I have no idea. How black holes can grow so big is a biting mystery of astronomy. A white hole, it's the reverse, kind of like I don't know. A white hole is an event horizon that is the reverse of a black hole event horizon. Nothing can pass into this horizon, just as nothing can escape from a black hole horizon. Roughly speaking, this is a definition of a white hole. With both the deep pit and the black hole, there's no other side. The bottom stops your fall through the pit, and the singularity stops your fall through the black hole, or at least the singularity no longer makes sense to say you're falling. Physicists believe wormholes may have formed in the early universe from a foam of quantum particles popping in and out of existence. Some of these primordial wormholes may still be around today. It is thought that the matter that goes into a black hole gets crushed to a tiny point at the center called a singularity. That is the only place that matter is. So if you were to fall into a black hole, you wouldn't hit a surface as you would a normal star. Once it's there, it's there. Judging from the number of stars large enough to produce such black holes, however, scientists estimate that there are as many as 10 million to a billion such black holes in the Milky Way alone. NASA scientists have identified the lightest black hole yet, just at 3.8 times the mass of the Sun, in a binary star system in the Milky Way known as XTE J1650 500. The next smallest black hole is spotted in 1994, weighing at 6.3 solar masses. As long as a wormhole has a greater mass than any black hole it encounters, it should remain stable. If a wormhole encounters a larger black hole, the black hole may disrupt the wormhole's exotic matter enough to destabilize the wormhole, causing it to collapse and likely form a new black hole. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. The most commonly known way of black hole forms is by stellar death. In general relativity, a white hole is a hypothetical region of space-time and singularity which cannot be entered from the outside. Also, energy matter, light, and information can escape from it. Click on link to learn more about black and white holes. Here's how black and white holes differ. White holes are lighter, and simply, black holes are darker than white holes. And right here is a link for what is a white hole. And here are some more links on YouTube to find out what blazars and black holes are.